This video is on the objective find an angle given two sides of a right triangle. So again, another video where we're only dealing with a right triangle. Alright, so a triangle that has a 90-degree angle in it, or a pi over 2 radian angle. So it's and this is the second video on this objective. Hopefully you've watched the first one as well. If you'd like to see more about the topic also, click on more instruction. Look at their videos, their notes, their examples. Hopefully all those help you out. So here we're given the triangle below, a right triangle. Right, you see the 90-degree angle here. Find the measure of angle theta, this angle theta labeled here, in radians, and round to 4 decimal places, right? So radians and not degrees. Right, just pay attention to that. Alright, so I've already drawn a picture of this. I got a calculator up, might as well keep it up because gonna need it in a second. So hopefully you remember your SOHCAHTOA. Sine is opposite over hypotenuse, cosine of an angle in a right triangle is adjacent over hypotenuse, and the tangent of an angle in a right triangle is opposite over adjacent. So hopefully you remember all that. We're trying to find this measure here, the measure of this angle. Well, this side length 4, right, this side with a length of 4 is the adjacent length to that angle. Right, that's adjacent to that angle. Now this side's also adjacent, but it is opposite the 90-degree angle. Right? Remember the side opposite the 90-degree angle is the hypotenuse. Okay. So now when we think, hey, I want to find this angle theta, I know the adjacent length, I know the hypotenuse, which of those trigonometric ratios involve the adjacent length and the hypotenuse, and that was the cosine. So I'm going to set up this equation here. So the cosine of theta, right, the cosine of theta is the adjacent length 4 divided by the hypotenuse 7. So the cosine of this angle is 4/7. And then we're solving this trigonometric equation. Now I only need to find one solution, right? I need to find a solution that's acute. This is an acute angle measure up here between 0 and pi over 2 radians. So to find just that one acute solution, all I need to be doing here is taking the inverse cosine of both sides. Right? So one solution to this that'll fit in my triangle is theta equals the inverse cosine of 4/7. All right, and let's punch that in. I've solved for theta. I can now this is the measure of that angle. But now let's punch that in and get the answer in radians. Now let's make sure I'm in radian mode, which right now I'm in degree mode. Okay, so I go change that to radian mode. I wanted the answer in radians. And I punch in the inverse cosine of 4/7. And to 4 decimal places, this is 0.962, and then you have 5, then 5 after that. So the 4th decimal place would round up to 6 if I'm rounding to 4 decimal places, right, the nearest 10,000th. And to see how many degrees that is, if you want, I multiply by 180 over pi. Remember that conversion factor from radians to degrees. So this angle is about 55 degrees. All right, this measure would be about 55 degrees, but again, we're asked to enter that in radians. So I'm going to go back and enter 0.9626, right, 0.9626. Right. Okay, simple as that. You just got to recognize which ratio, you know, if you're in a, again, it's in a right, these are in right triangles only. Just, you know, you're trying to find a missing angle measure. You know, what sides do you know? And what ratio could you use, you know, if you know those sides? If you know the adjacent hypotenuse, it's cosine. If you know the opposite side length from the hypotenuse, you'd use sine. And from the first video on this objective, right, if you know the opposite length and the adjacent length, you'd use tangent, and then eventually use inverse tangent to find the angle, right? Okay. So hopefully watching me do this, you know, looking at your more instruction when you need to, reading these answer explanations when they come up, hopefully all this stuff is helping you out when you're working on this material on your own. And thank you very much for watching.